So in this video, we're going to talk about graphing a parabola of the form ay squared plus by plus cx plus d equals 0, or ax squared plus bx plus cy plus d equals 0. And so basically, we have graphed parabolas back in Math 126. And so this is just a slightly different way to look at a parabola based on a conic section. So conic sections are all things that you can get by slicing a cone in different ways. So you can get a parabola if you slice a cone a certain way. And so in this case, what we're going to do, the first thing we're going to do is we are going to, when we're doing these problems, we're going to complete the square to get our problem to either look like this or like this. So it depends whether if the x squared term is, if the x is squared, it's going to look like this top one. And if a is greater than 0, it's going to open up or open down. And the bottom one, if the y squared term, if the y is the squared term, it's going to look like this, and that'll open to either side, which is a little different. We weren't used to doing those in Math 126. So let's give this a try here. So I have 2y squared plus 4y minus x plus 3. So right away, because the y is squared, I know that's going to open sideways. And so the first thing that I am going to do is I am going to solve this for x. So in this case, we're going to have 2y squared plus 4y plus 3 equals x. And I'm just going to rewrite it so x is on the left-hand side. So x is equal to 2y squared plus 4y plus 3. And now I'm going to want to complete the square. So when we complete the square, we just look at the squared term and the term that's to the first power. So just those two. And so I'm going to group them off first here. So 2y squared plus 4y plus 3. And then the next thing I'm going to do is I'm actually going to factor a 2 out of that parenthesis. So we're going to have 2 times y squared plus 2y. I'm going to leave a little bit of room plus 3. So the reason that I factored the 2 out is I want the leading coefficient on the y squared term to be a 1. So by factoring it out, the 2 out, I have a 1. And so now I can complete the square. So remember, when we complete the square, we look at the middle term, the y term here. We're going to take half of that middle term, so half of 2, which is 1. And then we have to square it. So 1 squared is 1. So we're going to add 1 in here. But we have to balance it off by subtracting something. Now the thing to notice is I didn't add just 1, I added 2 times 1, which means I have to subtract 2 times 1. So x is going to end up being 2. The inside stuff here is now y plus 1 squared, and then plus 1. So in this case, my h is going to be, so if we match it up with that formula I had on the other side, which says that x is equal to a times y minus k squared plus h. So in this case, h is going to be equal to 1, and k is going to be equal to negative 1, which means our vertex is sitting at 1, negative 1. And then it also means that our axis of symmetry is right here in the middle. So our parabola is going to go in this direction because our a is positive. So we're going to be opening here, this direction. And so to do that, I want another point. So we want to plot one other point. In Alex, you have to plot one other point. Plotting one other point here by hand is going to allow us to see what happens, is going to allow us to see what happens when we're drawing it. So if I look here, we can look at trying to, so we can pick other y values. So let's pick y equals 0 here. So if we let y be equal to 0, x is going to be equal to 2 times 0 plus 1 squared plus 1. So it's going to be 2 times 1 squared plus 1. So it's going to be 3. So I have also the point 3 comma 0. So if I plot here 3 comma 0, so now that allows me to kind of make my parabola on the right hand side, and then that 3 comma 0 would have a mirror image here at 3 comma negative 2, which allows me to plot roughly the other side. And Alex will make the plot pretty nice for you. So it's really a matter of getting it into the right form to be able to do these problems. So we'll try another one here. Let's go to another page. So let me put back in my graph here. Okay, so B, so minus 2x squared plus 20x minus y minus 53 equals 0. So in this problem, the x squared is the part that's, the x is the part that's squared. So we're going to solve for y. So I could just move the y to the other side. So minus 2x squared plus 20x minus 53 equals y. And now I'm just going to rewrite it so the y is on the left-hand side. So y is equal to minus 2x squared plus 20x minus 53. Again, we're going to look at the x squared term and the x term to be able to do completing the square. So we're going to have, and I'm going to factor out to make the leading coefficient of the x squared term a 1. So we need to factor out, in this case, a minus 2. So I have minus 2 times x squared minus 10x, and then I have minus 53. And so to complete the square, we're going to look at the minus 10. So we're going to take half of minus 10, which is minus 5, and then we're going to square that. So minus 5 squared is going to be 25. So I'm going to add 25 in. And then since I added 25 in, I also have to subtract. But in this case, remember, I didn't just add 25, I added negative 2 times 25. So I have to subtract negative 2 times 25. So we end up with y is equal to negative 2 times x minus 5 quantity squared. And then we would have minus 53 plus 50, so that's going to give us a minus 3. And again, we're going to compare to the formula y equals a x minus h squared plus k. So in this case, h is going to be equal to 5 and k is equal to negative 3. So my vertex is going to be at 5 comma negative 3. So if we go out to 5 and then down to negative 3, and then I just want to pick some other, I know that my axis of symmetry now is this way because we have an x squared parabola, so it's vertical. I also know that it's going to open down because my a is negative. So I just want to pick another value of x. So picking x equals 0 is usually an easy one. So if I pick x equals 0, y is going to be negative 2 times 0 minus 5 squared minus 3. So here I end up with y equals minus 2 times 25 minus 3. So y is going to be equal to minus 53. So that's pretty big to graph. So maybe I should pick something closer. So why don't we pick something pretty close to our axis here. We'll pick x equals 4. So y is going to be negative 2 times 4 minus 5 squared minus 3. So y is going to be negative 2 times negative 1 squared minus 3. So that's going to be negative 2 times 1 minus 3, or minus 5. So if we go to 4, and then we would go down to minus 5. So our parabola is going to go down this way. And then I can put the mirror image there of the minus 5 on that other side of the axis of symmetry. And so we have that little parabola opening down there. So the key to these problems is being able to complete the square find the vertex, graph the vertex, and then just pick a number to plot on one of the sides and then mirror it on the other side.